Hello guys, very good evening. Welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So today we are going to discuss TCP congestion control in computer networks for NIELIT 2023. So join and please mention your presence. Say just hi or hello. Hi Sujirio, good evening. Yes. Am I audible? Please confirm me once. Is my audio, video, everything is clear? And hope you will really enjoy this today's session. I brought some problems also, some practice problems also I brought, and please, yeah, join quickly. Am I audible? Please confirm me once whether my audio, video, everything is clear. Then I will start the session. Hemalata, good evening. I hope all of you are doing good. So let me start the session. So before I begin the session, just let me introduce myself. Yes, myself Murali Krishna Bukkasamudram. I am having 21 plus years of teaching experience, and I'm certified as International Engineering Educator through ISIP certification program. And also, I mentored more than 50,000 students across the country in different core areas of computer science and engineering. Those are theory of computation (TOC), operating systems (OS), computer organization (CO), computer network (CN), digital logic and design (DLD), information and communication technology (ICT). So this is my area of interest and also area of expertise. So this is about my brief profile. And meanwhile, yes, thank you. Hi Ashwin Kumar, good evening. So before I begin the session, please do subscribe the channel if you are not yet subscribed it. So it will be helpful in giving you the notification for the classes, as we are conducting a lot of classes for NIELIT and also for GATE fundamental series, and also some general sessions, workshops. So everything will be provided to you. So once if you subscribe, you can just get the notifications for these classes. Okay. Yes. Shall I start the session? Meanwhile, you can just share with your friends. Yes, and do like the session and also subscribe the channel. There is a workshop, free workshop we are conducting for GATE. So this workshop is regarding, you can understand 6 prime factors to secure All India rank under 100 for GATE 2024. By our expert faculty, Rakesh Talreja sir is having MTech from ISC Bangalore, All India rank 9, and he is having 12 plus years of teaching experience. And 23rd April, so that is on coming Sunday, you can attend this free workshop. So you can register for this workshop and you can attend this. Yes. Okay. Now these are the results of 2023 GATE, and this is a celebration day for this GATE 2023 and 24 aspirants. So we are having more ranks, and 62 ranks under All India of 50, and All India rank 10 we have 13 ranks. Under 100 we are having 107 ranks. And these are the 3 students. One is All India rank 1, 5th rank by Dhruv and Gautam secured the first rank in P&I, and the Sarv Verma has secured All India rank 4th in the instrumentation and All India rank 5th in the electrical. Okay, so these are some of our students who got top ranks, and I wish you all the best for NIELIT 2023 aspirants and also GATE 2024 aspirants. Okay, shall I begin the session? So meanwhile, if you have any sort of doubt, please ask me. Okay, and before I begin the session, please do share this class link with your friends so that your friends also can join and make use of this, as we are conducting some problems also today. Yes, please join quickly. So basically TCP congestion control. So congestion is nothing but too much traffic. So nowadays in a network, bandwidth is not an issue, and also network speed is not an issue. The only issue is too much of traffic. Okay, so whenever a router is congested with a lot of incoming packets, and if the router's outgoing capacity is less or buffer space is less, so there is a need for discarding of the packets. So in order to overcome this problem, what we have to do, we have to just take the precautionary action at the sender side. If you are able to control the sender not to send too many packets, then we can control the flow, and we can control the congestion. Okay, congestion is nothing but forming of bottleneck at a single router. So that leads to a lot of difficulties in the implementation. Okay. Yes, Sahil Malik, good evening. Yes, Sujiro is asking, how can I manage both college studies and also GATE preparation together? It's a very good question. So definitely I will take a separate session for that. So it is a bigger discussion. So proper plan is required for that college and also GATE preparation. So it depends upon in which year you are in, and also there are some people attending the GATE and attending for NIELIT courses who are working also. So for working people or for college going people, how you have to prepare, and we will take a separate session. So let us concentrate on this first now. Okay. Now congestion control. First of all, you have to understand what is a congestion and how we can control the congestion. Okay. I hope I am audible and visible to every one of you. So please do share the class information with your friends, and also please do subscribe the channel if you have not yet done it yet. Okay, so congestion is a network state where the message traffic slows down the network response time. Okay, your response time will be more when the too much congestion is there, just like traffic congestion. So when the packets are traveled in a network, so definitely there is a chance of too many packets at a particular router based on the route chosen. So in that connection, we have to control that congestion by means of different ways. So here the way of how we are controlling the congestion at the host level, so that is by the TCP protocol, TCP congestion control. That is what we are discussing. There are some global congestion control algorithms at the router level by the network layer. So like leaky bucket, token bucket, etc. So that is not what we are discussing right now. What we are discussing is at the host level, so source level, how we are able to control the congestion. So by estimating the seriousness of congestion, so we can avoid it by changing the phases in the policy. Okay. So clear policy I will explain, including some problems. Okay. All of you, what you have to do is please be in the session till the end, and you will really enjoy the session. I brought some animated content for understanding the slow start phase and congestion avoidance phase and congestion detection phase. Okay, now quickly I will just recap of main things required for the congestion control. So basically congestion leads to loss of packets in the transmission. So when too many packets are there, when buffer is not there, some of the packets might get discarded. And it is not possible to completely avoid the congestion, but we can limit it. And congestion free network is an ideal network where it means taking the advantage of all bandwidth in the network. And also, if a sender wanted to send any data, sender will maintain a window. So that window contains some frames. Those are called segments in the TCP. So window size is determined not only by the receiver, but also by the congestion in the network. So two things will decide the window, how many frames, how many segments you have to send from the sender side. That will be decided by two factors. One is the receiver's buffer space availability, flow control, and congestion window size. So usually we take the actual window size is the minimum of congestion window and receiver's advertisement window. Receiver's advertisement window means, so based on the buffer space available at the receiver, it will give the advertisement like 1 kilobyte or 2 kilobytes availability. So sender cannot send more than that, so that we can avoid the flow, so that receiver will not be spammed. And also congestion window also will give a warning that if you send too many bytes of data, there is a chance for congestion. So accordingly, we can adjust the sender's window size. So that's why the actual size of the window is a minimum of 2 windows. I hope you are understanding. Okay. Yes. Now coming to, yes. Yeah, 3 acknowledgement phase is also there. I will explain. So congestion policy, actually there are some terms here. CNWD or CWND is congestion window, and SS indicates slow start, and one maximum segment is 1 MSS, and SS threshold is a slow start threshold, and congestion avoidance is nothing but additive increase and congestion detection. So in a nutshell, I will tell you, in the congestion policy of TCP there are 3 phases. Every phase begins with a slow start, and it may move to congestion avoidance, and it may move to congestion detection. Congestion may be detected at any phase, either in the slow start phase or in the congestion avoidance phase. So there are 2 methods of detecting congestion. One is through timeout value, other one is through 3 acknowledgements. Okay, so that is the criteria. Yes, exactly. Sahil Malik. Yes. Rajesh, yes, I'm fine. Rajesh, how are you? Thank you. Okay, now coming to slow start. In a slow start, actually, window size exponentially increases. I will show you the diagram how the window size exponentially increase. So initially, we begin with 1 MSS. For every round, once if you get acknowledgement, window size will be doubled. Until the congestion is detected, you keep on sending more number of packets. So to stop this growth of exponential size, so we can put some threshold that is called SS threshold. Okay. So if I show you that particular diagram flowchart, you will understand. So first of all, I will explain in a slow start phase how the window size increases. So initially, congestion window is 1 MSS. 1 MSS means one maximum segment size. It may be 1 kilobyte or 2 kilobyte. You can decide. What is the segment size? We can decide during the connection establishment. Okay. So congestion window is 1 MSS. One segment will be sent. One maximum segment will be sent. After sending that, if you get an acknowledgement for that segment, in the next one round is finished. In the next round, we will increase the window size by 1. So that means 2 MSS. Again, if we send both the segments without waiting for acknowledgement, either segment wise you may get acknowledgement or both the segments together. Once if all the segments of window size 2 are acknowledged, then again we will increase the window size by 4. So that means it will be exponential. 2 becomes 4, 4 becomes 8, 8 becomes 16, like that. It will go till you reach the SS threshold or till you get the congestion, whichever is earlier. Congestion may be detected meanwhile while you are in the SS phase, or it may window size may reach to threshold value. That threshold is nothing but SS threshold. SS threshold is called the slow start threshold. Slow start threshold. Okay, now I hope you are understanding. Yes, Rajesh is asking. I took the classes from you for NIELIT. Thank you, thank you. Okay. Okay, that's great. That's great, Rajesh. And Rajesh is telling that he has taken classes from my NIELIT classes and he's joined in the scientist P. Okay, that's great. Earlier, I think, right? Okay, fine. Now coming to 4 segments if we send. So segment 1, segment 2, segment 3. So if all the 4 segments are sent, if you get acknowledgement, now that round is finished. Now next time you can send 8 segments. But meanwhile, if you get any of the congestion is detected, for example, then the reaction of TCP is different. How the TCP will be reacted when the congestion is occurred is depending upon how the congestion is detected. There are 2 ways. One is a timeout method, other is a 3 acknowledgements. I will show you in detail. So I hope every one of you understood this. Okay. So please, yes. Okay. So this is the slow start phase and 8 MSS will be the maximum. So now coming to once if slow start phase is done, once if you reach to SS threshold, we have to change the phase. What phase you have to change? We have to go for congestion avoidance. Congestion avoidance is also called as additive. So earlier exponentially window size has been increased. Now additively window size will increase. When the size of the congestion window reaches slow start threshold, the slow start phase stops and the additive phase begins. Slow start phase stops and additive phase begins. So that is the size of congestion window increased by 1 after the RTT. One round is finished. Let us suppose if you send 4 segments, let us suppose. If all the 4 segments got acknowledgement, the next window size will be 5. If all the 5 segments got acknowledgement, next window size will be 6 MSS. Like that it will increase. I will show you that diagram also. The congestion avoidance diagram you can see. Let us assume that SS threshold is N, for example. So that means we have reached to SS threshold, that is N segment. Then after sending all the N segments, if we get an acknowledgement, the next time we can send N plus 1 segments. If all the N plus 1 segments are acknowledged, for instance, then you can send N plus 2. This also will be continued. Till what extent it will be continued? Till you get the detection. That means congestion detection. So next is N plus 3. Like that it will continue. So I'll just repeat. Initially it begins with 1 MSS in the slow start. In the slow start, for every round, window size keep on increased, like 1 MSS becomes 2, 2 becomes 4, 4 becomes 8, like that. Okay. Then when it is changed to congestion avoidance, just additively it will increase. Linear growth. There is no exponential growth. Okay. And this increase also till congestion is detected. Once if the congestion is detected, again the same thing. How it is reacted based on how the congestion has been detected. So that is the criteria. Are you understanding? So please let me know if you have any doubt. Yes. And please do share with your friends and subscribe the YouTube channel for getting more notifications and for having an access to the free classes. Please. Yes. Okay. Now coming to till the congestion is detected, we go like this. Multiplicative decrease means after detection what happens. So detection can be done in two ways. One is the timeout value, other is the re-acknowledgements. Timeout is nothing but you have sent a segment, there is no news about the sent segment, and there is a need of retransmitting the same segment again. In a TCP, what happens is, once if you send any segment, okay, we will wait for some time. Okay, that is a timeout value by estimating some retransmission time. Okay, once if time is out, there is a need for retransmitting the segment. Okay, how can you retransmit? Assuming that the segment might have been dropped because of the congestion. When the timeout is occurred, there is a serious possibility for congestion because nowadays networks are efficient networks. Okay, packets are dropped only because of the congestion, most probably not because of noise or something else. So that's the reason strongest possibility is a congestion when the timeout is occurred. Timeout is occurred. How do you understand? How does the sender understand? When there is a need for the sending of retransmitting of segment. Okay. Now 3 acknowledgements is also weaker possibility. 3 acknowledgement means, for example, I send 3 segments back to back. First one it is received, second one is dropped somewhere and it is not received, but third one is received. In that case, repeatedly 3 segments will be sent by the receiver when there is a gap in the data. So in that case, we can say if at all if congestion is occurred, let us suppose if second segment is dropped, definitely third segment also would have been dropped, but that is not done. That means there is a weaker possibility for congestion. Okay, so the TCP reaction is stronger for the timeout detection. TCP reaction is weaker for the 3 acknowledgements. Now coming to the congestion detection, so how it is done, it happens, and also timeout value we can set based on the estimation of retransmission time. And also let's see, one diagram is there, you can just see this. Okay, just one diagram. This diagram is a summary of TCP congestion policy. Using this you can do any problem actually related to the TCP congestion. Okay, hope you are following, and we will do some problems also in today's session. Is it clear? I hope every one of you are understanding. So this flowchart, if you observe clearly, any TCP congestion policy starts with a slow start. That means congestion window size, CWND means congestion window size, will be started with 1 MSS, 1 maximum segment size. Okay, so in slow start, how the window size increased, you know. First you start with 1 MSS, again you will increase it 2 MSS, then 4 MSS, till what extent it will go? Till the congestion window reaches to SS threshold. If at all, if congestion window is greater than or equal to SS threshold, we don't go beyond the SS threshold, we keep the congestion window equivalent to SS threshold. But during the slow start also, before reaching to SS threshold also, there is a chance of congestion. If at all, if congestion has been detected through timeout, not 3AC case. 3AC case is wrong here. On the right side, 3AC case. If the congestion is detected through timeout, SS threshold value will be half of the congestion window. For example, let us suppose SS threshold value we have created initially for 16 MSS. Then after the congestion is detected through timeout, we make the SS threshold value half of the present window size. Let us suppose present window size is 16 MSS. So half of that means 8 MSS will become SS threshold. And congestion window is equivalent to 1 MSS because it will continue back in the SS phase. Okay. For example, congestion is not detected during slow start. It has gone to congestion avoidance phase once if congestion window reaches to SS threshold. So now exponential growth stops and congestion window increases linearly, that is called additive increase. But during this phase also congestion might be detected. If congestion is detected through timeout in this phase, same reaction. SS threshold value is half of the, that's what multiplicative decrease, half of the present window, and the congestion window is equivalent to 1 MSS. And if you get 3 acknowledgements either in the slow start or in the congestion avoidance, so 3 acknowledgements means SS threshold value half of the congestion window, and the congestion window we will continue in the congestion avoidance phase only when you get congestion detection through 3 acknowledgements. We will continue in avoidance phase, we don't go for slow start. That's why congestion window size is equivalent to new SS threshold value. Congestion window size is equivalent to new SS threshold value. I hope you understood. Okay, so this is the criteria. By looking at this diagram, you can answer any type of question related to this TCP congestion policy. Okay, now any doubt or any concern, you can just chat with me. I will answer these questions. Okay, now. So I will just once again briefly explain. Initially, we start with slow start. During slow start, if congestion is detected, there are two methods. Timeout. Through timeout, if it is detected, SS threshold value we make half of the present congestion window, and we will continue in the SS threshold by going back with 1 MSS. If at all congestion not detected during slow start, if congestion is detected through 3 acknowledgements in the slow start, we will make the SS threshold value half of the congestion window, and the congestion window is equivalent to new SS threshold, and we will continue in congestion avoidance. If nothing is happened in congestion, the slow start phase, we will move to congestion avoidance phase once if it reaches to SS threshold. What is reaches to SS threshold? Congestion window. Once if congestion window is greater than or equal to SS threshold, congestion avoidance phase begins. In the congestion avoidance phase, if the congestion is detected through timeout, then we will make the SS threshold value as it is, half of the congestion window, and the congestion window is 1 MSS, and continue in slow start, go back. If it is detected through 3 AC case, then congestion window SS threshold value half of the 0.5 means half of the congestion window, and congestion window is equal to new SS threshold, and continue in the congestion avoidance. That is the criteria. Hope you understood. Okay, now let us do some problems here. So if I explain the problem, then it will be more clear for you. Assume that the SS thresh value during the start of the first transmission is 16 MSS. SS thresh value during the start of the first transmission is 16 MSS. Okay, so 16 MSS is the SS thresh. Okay, now the timeout occurs during 8th transmission. What is the value of congestion window during 11th transmission? So what is the phase here? I'll just explain the phase. You can just slow start phase. For instance, we started with, just a moment, we started with slow start. Initially slow start. In a slow start phase, during the first transmission, we will send how much? 1 MSS. Okay, and the timeout is occurred during the 8th transmission. Observe carefully. During the second transmission, as it is a slow start, it will become 2 MSS. During the third transmission, it will go for 4 MSS. During the fourth transmission, it will go for 8 MSS. Okay, during the fifth transmission, it is 16 MSS. So 16 MSS means it has reached to threshold. SS threshold is reached. That means we have to change the phase. SS threshold is reached. We have to change the phase. What phase we have to change? We have to change to congestion avoidance. This exponential growth we have to stop. That's the reason threshold is kept. Congestion is not detected yet. During 8th transmission, timeout is occurred. So during the 6th transmission, we have to go for a congestion avoidance phase. So after all the segments are acknowledged, next size will be 17 MSS only. Okay, during the 7th transmission, okay, we can send 18 MSS. So during the 8th transmission, we can send 19 MSS. So 19 MSS when you reach, then we got a timeout. That means congestion has been detected. When the congestion is detected, we have to change the phase because of timeout value. So we have to again go for the slow start. But we have to make SS threshold value half of the present window as per the diagram. SS threshold is equal to 0.5 into 19 MSS. 19 MSS is what we will get around 9.5. Around we can round figure 10 MSS. SS threshold is 10 MSS. Now during the 9th transmission, as we are going to SS threshold, because of the timeout, only 1 MSS will be sent. During the 10th transmission, again slow start, right? 2 MSS. We have to continue till we reaches to SS threshold. During the 11th transmission, it will go up to 4 MSS. Okay, what is that the question is asking? During 11th transmission, what is the value of congestion window? It's a 4 MSS. Because 9th, 10th, 11th is in slow start only. Still we have not yet reached to new threshold. Okay, so that is the criteria. I hope everybody understood it. And if you get any doubt in this, please let me know. So 4 MSS is the right answer here. Okay. Is it clear? This problem is clear? Okay. Now coming to second question. Yes. And if you have any issue, please let me know. Assume that SS threshold is 8 MSS initially and the timeout occurs during 5th transmission. What is the congestion window during 12th transmission? This is a little bit bigger. Can anybody tell me this? Am I audible? Please do like the session if you are really liking it. Okay. Yes. Please let me know. Okay. I'll continue. Now, first of all, SS threshold is 8 MSS, right? Initially, we begin with slow start, right? During the slow start, first transmission, we send 1 MSS. During the second transmission, we send 2 MSS. During the third transmission, we send 4 MSS. During the fourth transmission, 8 MSS. So 8 MSS means it is reached to SS threshold. But timeout is occurred during the fifth transmission. SS threshold is reached. So we have to change the phase. So congestion avoidance phase. So during the fifth transmission, if all the 8 segments are acknowledged, next would be 9 MSS only. Additively we increase. So in this case, we got actually timeout. Timeout means how the TCP is reacted. Timeout is occurred. How the TCP is reacted? It will go back to slow start, but it will make the SS threshold half of the present window. SS threshold is equal to 0.5 into 9 MSS. So this is nothing but 4.5, around 5 MSS. Let us see. Okay. So during the sixth transmission, as we are in SS, again we have to go for 1 MSS. Okay. During the seventh transmission, 2 MSS. Observe carefully. So during the eighth transmission, it is 4 MSS. Still it is not reached to SS threshold. What is the new SS threshold? 5 MSS. And why we have gone to 1 MSS? Because we are going back to SS when the timeout is occurred. So I will write ninth transmission here. So during the ninth transmission, actually it should be 8 MSS. So 8 MSS is greater than or equal to 5 MSS. So we can't go beyond 5 MSS. So that is the diagram says. So if you see this diagram, if the congestion window greater than or equal to SS threshold, we have to keep it SS threshold. That's why we have sent only 5 MSS because it is reached to SS threshold. Then we have to change the phase. What phase you have to change? We have to go for congestion avoidance phase. In a congestion avoidance phase, during the 10th transmission, 6 MSS. Am I right? Okay. During the 11th transmission, it is how much? 7 MSS. So during the 12th transmission, it is 8 MSS. So 8 MSS would be the right answer. So during the 12th transmission, you will send 8 MSS in the congestion avoidance phase. Hope you understood. Is it clear? During the 12th transmission. Okay. Yes. Shall I go to the next problem? I hope everybody understood this. Yes, Malik, is it fine? I will go to the next question number 3. Yes. Now I think you only can answer this. One different AIMD is nothing but additive increase and multiplicative decrease. Additive increase is for congestion avoidance. So initially we begin with slow start only. Some of you can answer it, I think. Consider an instance of AIMD, additive increase, multiplicative decrease, for congestion control in TCP. It begins with a slow start, SS. The value of SS thresh during the first transmission is 16 MSS. SS thresh is equal to 16 MSS. SS thresh is equal to 16 MSS. And 3 acknowledgements are received during the 8th transmission. What is the value of congestion window during 10th transmission? Okay. So first phase is slow start. During the slow start, during the first transmission, we send 1 MSS by default. Okay. During the second transmission, we send 2 MSS. During the third transmission, what we send? 4 MSS. And when the 3 acknowledgements came, 8th transmission. During the 4th transmission, 8 MSS. Still we did not reach to SS threshold. During the 5th transmission, we sent 16 MSS. Still we did not get any timeout, but we reached to SS thresh. We reach to SS thresh, then we have to change the phase. What phase you have to go with? Congestion avoidance. During congestion avoidance, during the 6th transmission, we don't change the SS thresh just because congestion is not yet detected. During the 6th transmission, it is 17 MSS. During the 7th transmission, it is 18 MSS. Linearly, it will increase. Are you following? Hope so. It was initially SS threshold value. Okay, now 18 MSS is there. Now during the 8th transmission, 19 MSS. 19 MSS. But during 8th transmission, 3 ACKs were received. When 3 ACKs are received, what to do? SS threshold value is half of the present window, half of the 19 MSS. It will become 9.5, around 10 MSS, we can round it. SS threshold value 10 MSS. Now, as 3 acknowledgements are arrived, we have to continue in congestion avoidance, not in the slow start. So, during the 9th transmission, it will be 20 MSS. No, just a moment. It is wrong, right? Just a moment. So, actually what we have to do is, during the 9th transmission, we should not continue with the increase of the 8th, because SS threshold value 10 MSS and congestion window is equal to new SS threshold. What is the new SS threshold? 10 MSS. So during the 9th transmission, if I send 10 MSS, during the 10th transmission, as you are in the avoidance phase, it will become 11 MSS. So 11 MSS is the right answer. Hope everybody understood this. 11 maximum segment sizes. So that's all for today. I hope you people have enjoyed the session. And if you have any doubt, please ask me. Even after the class is finished, you can use the comment box for posting your doubts. Okay, now that's all for today, and thank you so much. Thank you one and all. Have a good night. See you once again in the next sessions. Thank you.